In this paper, we study the ability of a robot to auto-generate its own self-model. We will show how a robot can model its entire forward kinematics without any prior knowledge or assumptions about physics, geometry, or motor dynamics. We conducted our experiments using a 4-degree of freedom articulated robotic arm. Initially, the robot moved randomly and collected approximately 1,000 trajectories, each comprising 100 points. The robot then used a deep sequence-to-sequence model to create a self-model consistent with the data that it had collected. Here, you can see some of the initial self-models overlaid on top of the real robot. Initially, the models were very inaccurate. The robot had no clue what it is, or how its joints are connected. However, after approximately 34 core hours of training, the self-model became consistent with the physical robot to within about 4 centimeters. The self-model was good enough to allow the robot to use a simple internal planner to perform a pick-and-place task in closed loop with 100% success. Even in open loop, the robot was able to complete the pick-and-place task with 44% success. That's like trying to pick up a glass of water with your eyes closed, a process difficult even for humans. The same self-model, without any additional training, could be used for other tasks. For example, here, the robot is writing text using a marker. A self-model is also useful for allowing the robot to detect changes to its own morphology due to damage, wear, or adaptation. For example, here, we replaced one of the robot arms with a longer, slightly deformed part. The robot automatically detected the change and reimagined its self-model. The deformed robot could then resume its task with little degradation in performance. In this paper, we showed why there's a strong incentive for a machine to learn to create a precise self-model and then reuse that self-model repeatedly to learn new tasks. We believe that this separation of self and task may have also been the origin of self-awareness in humans.